Hello, we will now review some of the material from Chapter 4. This isn't going to cover everything on Chapter 4, but it covers kind of the main topic areas. There's a lot of different terminology in Chapter 4, so that you need to make sure and know. So I encourage you to look back at your book and your notes and to think about, to study that and to think about it and ask questions about that. But so let's look at this. So this says, McGill wishes to randomly select 30 students from his high school, which has 1,500 total students. All right, describe a method he could use. So we want to randomly select 30, a sample of size 30 from a group of 1,500. And so this is what you must do. You must do three things in essence. You must assign them all numbers, use a random number generator to generate your sample, and say that it's the people with those numbers that are in the sample, not the numbers themselves. So you would say assign each of the 1,500 students a unique integer from 1 to 1,500. So say it just like that, a unique integer, and then from 1 to 1,500. You must say that as well. Don't just say a unique integer. Say it from 1 to 1,500. You could say distinct integer, or you could also say an integer ignoring repeats, but you must say from 1 to 1,500. Okay, all right. So use, and then second sentence, use a random number generator to create 30 unique integers from 1 to 1,500. And you have to say it just like that. You can't leave out the 1 to 1,500. Please don't. You have to say unique integers or distinct integers or integers ignoring repeats. Okay. And then just say the students with those 30 integers are in the sample. It's not the 30 integers, it's the students in this case. That's how you do it. Sorry, that's one of the ways. The other way is the hat method, which I won't go through now. Okay, so that's number one. Number two, a blank sample is when the population is divided into groups and some members of each group are selected for the sample. And that is a stratified sample. It's dividing into groups, taking some from every group. Ideally, it's done if the groups are homogeneous. In other words, if they're the same within the sample and they differ from each other. So that would cause you to stratify. And if you stratify properly in that way, you'll have less variability in your responses. Number three, a blank sample is when the population is divided into groups and one group or a small number of groups is chosen to be surveyed. Okay, that is what we call cluster sampling, when you divide into groups and you pick in essence one group to represent the whole. So if the groups are heterogeneous, this would be a good thing to do. You could just select one group or a small number of groups to represent the whole. Or sometimes you'll see in cluster sampling, they'll divide them into groups and they'll pick one of the groups and then do a random sample within that group. That would also be cluster sampling. So number four, a blank sample is when every group of size n is equally likely to be chosen. That is a simple random sample. When every group of size n is equally likely to be chosen. Now, just a random sample means that everybody in the population is equally likely to be chosen. So a simple random sample is more specific than that. Number five, a farmer has invented a new fertilizer that he claims causes potatoes to grow much larger than normal. He says that when he used the fertilizer, the potatoes ended up being 40% larger than normal. Explain how the concept of confounded variables could be involved in this situation. The concept of confounded variables, whenever someone is making a claim that one variable is causing a change in another variable, we should always say, wait a second, there could be another variable involved. And maybe that is this other variable that is causing the result. And so the key thing there is that you have to make the connections between all three of the variables: the explanatory variable, the response variable, and then the other variable. Okay, that's the key thing. So in this case, the explanatory variable is the fertilizer or not. The response variable is the size of the potatoes, and the other variable could be, let's say, the amount of water, the rain. So this is the way I worded this. There may be another variable involved. For instance, maybe it rained an unusual amount of time during the time that the plants got fertilized. So that's connecting the rain with the fertilizer. You got to do that, okay? Maybe it was the increased rain that caused the potatoes to grow so large. So that is connecting the other variable, the rain, with the response, the size of the potatoes, though it appeared to be the fertilizer. So I've connected all three variables. That's what you have to do. Okay, and so that's explaining a confounded situation. Two confounded variables are two variables such that their effect on a response cannot be distinguished. Their effects on the response cannot be distinguished one from the other. Is it the rain or is it the fertilizer that's causing the potatoes to grow large? We don't know. And so those variables are confounded. The answer to this situation is a controlled experiment. That is what we need. That's what we can do to definitively say whether or not the fertilizer is working, and have both the fertilizer group and the no fertilizer group both get the same amount of rain. So it's obviously not the rain causing the change in the potatoes. It must be the fertilizer, if the fertilizer is the only difference between the two groups. But anyway, I don't want to start rambling. Number 6, and blank is a type of study when a treatment is imposed on those being studied. That is an experiment. Okay. If it's a good experiment, it'll be comparative. You have comparative groups such as a control group. All right. So that's number 6. Number 7, a doctor wishes to see if a new drug works in lowering the bad cholesterol LDL of people who have high LDL. He has 80 people with high LDL. This should say high LDL. High LDL. That are available to participate in an experiment, design an experiment for the doctor. So you have to do 3 things when you design an experiment. You have to clearly state how you're randomizing into treatment groups. You have to clearly state what's happening in the treatment groups. And you have to clearly state how the results are being compared between the groups. You got to do those 3 things. So let's do those 3 things. First of all, randomization, right? And I'll use the hat method here where you're writing the names on pieces of paper. Write the names of the 80 subjects on pieces of paper that are the same size and well mixed. That's important that you say the papers are the same size and well mixed. That takes care of randomness. All right, select 40 pieces of paper blindly. The subjects with those names on those 40 pieces go into the group that sees the drug for 3 months. The other 40 receive a placebo to take daily for 3 months. So I've clearly stated how I've randomized it, and I've clearly stated what's happening in the treatment groups. Okay. I used to like to include a sentence here saying that otherwise the groups are treated exactly the same, but it's not necessary. And then, so the only thing left is stating how I'm going to compare results. After 3 months, compare the improvement in LDL between the drug and the placebo groups. Common mistakes here is that don't just say compare results generically. Say compare what it is you're comparing, the improvement in the LDL, and then between the 2 groups. Don't just stop here. Say between the drug and the placebo groups. So that's how you design an experiment. There you go. And that's the answer to number 7. In number 7, what would cause you to block the experiment on gender, and what would be the result if you properly block? You block if there's a difference between the 2 groups. If there's a difference in the males and females, you have reason to believe in regards to the relevant issue, which in this case is in regards to this drug and the cholesterol. And so, and if you properly block, there'll be less variability in your responses. So what we would say is this: you would block on gender if the genders differ in regards to how their LDL level would respond to the drug. That's what causes you to block, okay? This would lead to less variability in our results. So whenever you properly block, or when you properly stratify in sampling, if you do it properly, there'll be less variability in your results. Okay. And the only difference between blocking and stratifying is blocking occurs in an experiment. In other words, blocking occurs when you're imposing a treatment. Okay. And then lastly, we say that an experiment is blank blank if neither the subjects nor the people working hands-on with the subjects know who's getting what treatment. And that's what we call double blind. That's to prevent any sort of experimenter bias, and to make sure the placebo effect doesn't raise its ugly head. So anyway, so that's it. If you have any questions about chapter 4, then let me know. And like I said, there's more to chapter 4. There's a lot more terminology, so make sure and study it. So, okay, thanks for watching the video.